Hello friends, in this video we are going to solve a problem based on the quality factor meter or Q meter, which is also known as the RLC meter. So let us start with our topic. So our problem is we are given a circuit which is consisting of a coil, a resistance and a variable capacitor which are connected in series, and this circuit is tuned to resonance using a Q meter. Now if the frequency is 500 kilohertz and the value of resistance is 0.5 ohms and the variable capacitor is set to 350 picofarad, we have to calculate the effective inductance and resistance of the coil if the value of the Q meter is 90. Okay, so this is our problem and let's try to solve it. Now in the question we are given the value of the resistance as 0.5 ohms, means we are having a coil, we are having a resistance and a capacitor, and these three are connected in series with each other. Now the value of inductance, if we see, we are measuring the quality factor by connecting this circuit across a Q meter. Now through the Q meter we can measure the inductance by the formula one upon 4 pi square F naught square C. How this formula is coming? Because the Q meter, in the Q meter the circuit is tuned to the resonant frequency. So at the resonance frequency XL is equals to XC. Now we know the value of XC is 1 upon omega naught C and the value of XL is omega naught L. Okay, so this omega naught, it is equal to 2 pi F naught. So XL and XC, they are equal to each other, so we are going to put the value of omega naught here and then equate the value of XL and XC. So we will get 2 pi F naught L is equal to 1 upon 2 pi F naught C. So through this we will get the value of F naught as 1 upon 2 pi under root of LC, and also through this equation we can get the value of L as 1 upon 4 pi square F naught square C. So we are getting the value of inductance through the resonant frequency equation. XL is equals to XC. Now we are going to use this equation to find out the value of the inductance. So L will be equal to 1 upon 4 into pi square into F naught. F naught is given to us in the question as 500 kilohertz. So we are going to convert it into hertz. 500 into 10 raised to the power 3 and because we are having F naught square, so there will be square of it. And then the value of capacitance is given to us as 350 picofarad. So 350, and because it is in picofarad, so we have to convert it in farads. So it is multiplied with 10 raised to the power minus 12. So if we solve this, we will get the value of L in the units of Henry, because we have converted the kilohertz into hertz and capacitance microfarad, picofarad into farads. So we will get the standard unit of the inductance as Henry, and after solving it, we will get the value as 290. The unit for L is Henry here. So because here we will get 10 raised to the power 3 square. So it will be 10 raised to the power 6, and here we will have 10 raised to the power minus 12. So it will be 10 raised to the power minus 6, and when we will convert it, we will get it at 10 raised to the power 6. So we are going to put it here micro Henry. Okay, so L will be equals to 290 micro Henry. Okay, now we have to measure the resistance also, resistance of the coil. This was the inductance of the coil. Resistance, because we are already given that in the coil is connected with a resistance and a capacitor with it. So both the resistances will be added, that is the resistance plus the effective resistance plus the resistance which is connected in series with it. So R plus the value of the resistance given to us is 0.5, that will be equal to the omega naught L by Q. Because we know that the quality factor Q, it is equal to the ratio of omega naught L upon R. Okay, and R is the effective resistance. Now along with the effective resistance, this resistance is also added in series with it. So total value is written here, and it will be equated to omega naught L upon Q. Now putting the values of L, omega is what? Again 2 pi F naught. So we can write 2 pi F naught L upon Q. So 2 pi into F naught is the frequency, which is again 500 kilohertz. So it has to be converted into hertz. Then we are having L. L we have already calculated earlier. It is 290 microhenry. So we will write 290 microhenry is converted into Henry. So multiplied by 10 raised to the power minus 6 divided by the quality factor Q. Now in the question we are given that the reading of the Q meter is 90. So we are going to put it here, the value 90. Now when we are going to solve it, we will get the value of R as 10.25 ohms. First we will solve this. We will put the value of pi as 22 by 7, and then solve this, and then minus 0.5 from this, and then the value of the resistance will be 10.25 ohm. Now because this is the collective value which we are getting, R plus 0.5. So R will be equals to 10.25 minus the 0.5. So it will be equals to 9.75 ohms. So what is this? This is the effective resistance. Of the coil. Because in the question we were having the coil, this was our coil. which is having the value of R also and L also. L was the effective inductance and R was the effective resistance, and this coil is connected in series with the resistance and the capacitor. The value of this resistance was 0.5 ohm and the value of capacitor was 350 picofarad, and we were given that the Q meter reading is 90. So using all these informations, we have used the formula for inductance as 1 upon 4 pi square F naught square C, and for the measurement of resistance we have used the formula that Q is equals to omega naught L by R. L we have already calculated, so we are going to just put the values here and then calculate the resistance. So in this problem we have this problem was based on the measurement of the inductance and the effective resistance of the coil when the other informations were given to us. So similarly, the problems which are based on this can be found out by using the formulas given in the problem to us. So I hope that this problem is clear to you. Thank you.